Okay, this is part 2 of lecture 5, and what I wanted to do here was just to have a quick look at the final example and just work through it step by step so that you can see what's going on. So if you remember that example, the idea is we've got a PDF which is f of x equals 1 over 6, and that's defined for values of x between 0 and 6, and it's equal to 0 otherwise. Okay, so one of the first things I want to do then is just to check that this is a valid PDF, and the way to do that is to check that the integral between negative infinity and plus infinity of f of x with respect to x is equal to 1. Okay, so let's see if we can do that. So let's think about that integral. So let's think about the integral between negative infinity and plus infinity of f of x with respect to x. Now in this particular case, that's just going to be equal to the integral between 0 and 6 of 1 over 6 with respect to x. And in turn, that's going to be the definite integral, 1 over 6 times x computed between 0 and 6. And you can see that that's very clearly just 1 over 6 times 6, take away 0, which is equal to 1. So that checks out okay. This is indeed a valid PDF from that perspective. The second thing I want to do is to compute the variance of x, the expectation of x. So let's think about the expected value of x. Now we know from the formula that that's going to be given by the integral between negative infinity and plus infinity of x times f of x with respect to x. Okay, or in this case, that's going to be the integral between 0 and 6. Remember, this PDF is only defined between 0 and 6. So it's going to be the integral between 0 and 6 of 1/6 of x with respect to x. And if we integrate that, then we get the definite integral of 1 over 12 x squared evaluated between 0 and 6, which is 36 over 12, take away 0, which is equal to 3. So that's what we said on the slide, and that is indeed the expected value of x in this particular example. And then finally what I want to do is I want to work out the variance of x. And the variance of x is going to be the integral between negative infinity and plus infinity of x take away mu, which is just e of x all squared, times f of x with respect to x. Okay, so in this case that's going to be the integral between 0 and 6 of x take away 3 all squared times f of x with respect to x. And then if we expand that out a little bit, that's going to be the integral between 0 and 6 of 1 over 6 x squared take away x plus 3 over 2 with respect to x. And then if we do our integration, then what's that going to give us? Well, for that first bit it's going to give us 1 over 18 x cubed between 0 and 6, take away a half x squared evaluated between 0 and 6, and then add on 3 over 2 x evaluated between 0 and 6. Let me just adjust this camera so I can see what's going on. And I think you can see that if you work out what that is, what's 6 cubed? 216. So we've got 216 divided by 18, which is 12. The 0 cancels out, so that we don't have to worry about that. Take away, we've got 18 in there, 36 divided by 2, and then plus 9 there, which turns out to be 3 as well. So the variance of x is also equal to 3, and if we wanted to, we could work out the standard deviation. So remember, that's just what we called x squared in the lectures. Okay, so ends lecture 5.